Hi, in this video I am doing level 1 part 3, it is a trigonometry. I suggest please watch my previous videos of level 1 part 1 and part 2, then it will become very easy to follow this video. Chalo, let us start. In part 3 we are going to talk about trigonometric ratios. In fact, actual topic starts from here. So let us start with the trigonometric ratios. So when you look at the word ratio, immediately we get in our mind that is some A is to B. If there are two numbers A and B, then A is to B will be the ratio. Even here we are using the same thing, but remember every A is to B you can write as A divided by B or A over B. Then we need two numbers to write a ratio. Then how these trigonometry ratios are established? Uh, Let us take a right angle triangle. As we know, the trigonometry, 90% of the trigonometry uh, is built based on right angle triangle. So just I am taking a right angle triangle. Say this is a 90 degrees over here, and one of these two angles. Let us take any one angle as theta. Here I am taking, no problem. Anything you can take. Even here you can take the theta. With respect to this acute angle theta, all the three sides are named like this. Opposite to acute angle theta is called opposite side. Shortly I am writing OPP, opposite side, you need to understand. And opposite to 90 degrees, that will be hypotenuse. And the remaining side, which is joining theta in 90 degrees, is adjacent. Here opposite means you need to understand is length of this side, adjacent in the sense length of this side, and hypotenuse is length of this side. Length in the sense it must be a number, means overall here we have three numbers 1, 2, 3. So from three available numbers, taking two numbers at a time, we can write a ratio. Means if I take this number and this number, I can write ratio like that. Taking two numbers at a time from three available, we can establish six ratios. Those six ratios are named by particular name, and that we are writing here. So let us start with the first ratio, that is opposite over hypotenuse. That is called sine theta. Theta is the angle whatever you are taking here. Means the with respect to this angle we are writing all the trigonometric ratios. Sine theta is nothing but opposite divided by hypotenuse. And the second one, cos theta. This is adjacent divided by hypotenuse. And then tan theta. This is opposite divided by adjacent. These three ratios are called primary ratios. And if we take reciprocals of these two, we get the secondary ratios. So let us take the reciprocals of this. Reciprocal of opposite by hypotenuse is hypotenuse by opposite. Just flip it vertically. Then that is called cosecant theta. It is hypotenuse divided by opposite. And flip this vertically. Hypotenuse by adjacent, that is called secant theta. It is hypotenuse by adjacent, and reciprocal of this is called cot theta. It is adjacent divided by opposite. So these first three are primary, second three are secondary, and the first three primary are reciprocals of secondary three. Means sin theta and cosecant theta are reciprocals to each other. Cos theta and secant theta are reciprocals to each other. Tan theta and cot theta are reciprocals to each other. In fact, here we are writing only short forms. Actually, these all the six ratios has their full forms. Let me give all the full forms of these six ratios. Uh, just we are writing SIN sine. In fact, its full form is SINE, and we write just the cos, but it is nothing but cosine. And I write tan in short form, but its full form is tangent. And the remaining three. Cosec I write in short, but it is cosecant. And then secant I write in short, but it is secant. And in short, I am writing cot, but in fact it is cotangent. So every time you need not to write the full form, just we are using short forms every time. And further, here this all about the basic trigonometric ratios. And here since these primary three are reciprocals of secondary three, we can establish the relation between all the six by using the reciprocal concept. So let us see what is the reciprocal concept and how do we establish the relation between them. Okay. Let me take from here onwards as for your understanding better I will take point wise. Uh, since we know sine theta and cosecant theta are reciprocal, that in the sense we can write sine theta is equal to 1 divided by cosecant theta, or cosecant theta is equal to 1 divided by sine theta. And if for example if x and y two numbers are reciprocals to each other, we can write x is equal to 1 divided by y, or y is equal to 1 divided by x, or x into y is equal to 1. Even here, or else you can understand like this on cross multiplication, we get sine theta into cosecant theta is 1. This is the relation between sine and cosecant. Similarly, we can establish the relation between cos and secant. Let us take this is some a part, and I am writing as b for the relation between the cos and secant. Since cos theta and secant theta are reciprocals, cos theta we can write as cos theta equal to 1 by secant theta, and secant theta you can write 1 by cos theta. So from this, cos theta and secant theta is equal to 1. The trigonometry, especially everything based on the formulae, until unless you are uh, very much hold on the formulae, you cannot solve the questions properly. Next, relation between tan and cot. Since they are reciprocals to each other, tan theta we can write 1 divided by cot theta, and cot theta is 1 divided by tan theta, and from this tan theta into cot theta is equal to 1. Okay. And one more relation we can do, that is tan theta can be expressed in terms of sine and cos the same way cot. So under part D, I am writing the relation tan theta is equal to, you can write sine theta over cos theta, and reciprocal of this cot theta you can write cos theta by sine theta. So under Point 1, we could establish the relation between them. These are the basic information about the trigonometric ratios, and followed by here for different values of data, all the 6 ratios should have some value that we establish in a small tabular format. And moreover, usually we come across with the angles 0 to 90 degrees, and using that we can calculate even for any higher angles also. Just let us have a small tabular format to understand better uh, the values of trigonometric ratios for different angles. Presently I am taking angle 0 to 90. So I am taking in second bit as values of trigonometric ratios for angles 0 degree to 90 degree. Let us have a table to remember easily. That I am making 4 rows. This is for sine and cos and then for tan. And here in columns I am taking one column for 0 degree, next 30 degree, 45 degree, 60 degree and 90 degrees. Here I wanted to give complete the concepts of trigonometry, but not any shortcuts. Whenever we go through the questions, then I'll be explaining the shortcut techniques. So don't expect shortcut techniques in these concepts videos. Uh, these are the usually we come across with the angles 0 degree, 30 degrees, 45 degrees, 60 degrees, 90 degrees for different ratios, how these takes the values. So in later videos, I am going to give the shortcut techniques how to memorize all these values. But right now, I am giving it in proper way as a subject. So sine 0 will be 0, sine 30 will be 1 by 2, sine 45 is 1 over root 2, sine 60 root 3 divided by 2, sine 90 is 1. And then cos 0 is 1, cos 30 is root 3 divided by 2, and cos 45 1 by root 2. Sin 45 and cos 45 takes the same value, and cos 60 is 1 by 2, and this is 0. Then tan, it is sin by cos. From this above 2 rows you can write the tan values. That is tan 0 is 0, and tan 30 is 1 over root 3, tan 45 1, tan 60 root 3, and tan 90 is infinite. So I think this table is sufficient to find all values, 6 ratios, but because since we know sine, cos, tan are uh, reciprocals to other 3. Once you got these values, the remaining values you can find out by taking reciprocal. See, for example, I require some secant 45. So since secant is reciprocal of cos, here cos 45 value is 1 by root 2. Then secant 45 must be reciprocal of these two, root 2 by 1, or simply we take root 2. And for example, I want to know cosecant 60. From this table, let us take sine 60 because of cosecant is reciprocal of sine. So from this table, sine opposite under 60, sine 60 value is root 3 by 2. Then definitely cosecant 60 must be reciprocal of this 2 by root 3. Like that you can find out the remaining values also. So thank you very much guys. See you in next video. Thank you very much for watching this video.